Okay, let's use what we know about geometric sequences to write some explicit formulas. So in this problem, we're asked to write the explicit formula for this geometric sequence and then determine the 12th term. So let's start with our formula. A sub n equals a1 times r to the n minus 1. And in order to write the explicit sequence, we're going to have to determine the first number in the first term in the sequence and the common ratio. So the first term in the sequence is going to be very easy. It's just this right here, 5. So that was easy. And then we're going to have to determine the common ratio. So what do we do to go from 5 to 15 that we also do to go from 15 to 45? Looks like 5 times 3 is 15, and 15 times 3 is 45. So that was simple. Our first term, a1, is going to be 5, and our common ratio, r, is going to be 3. So we're now ready to write our explicit formula. Our explicit formula is a sub n, the nth term, equals our first term, 5, times our common ratio, 3, raised to the n minus 1 power. Now they tell us to determine, or our next step is to determine the 12th term. So we know that the 12th term, a sub 12, equals 5 times 3 to the, and since n is 12, we're going to put 12 right here, and we're going to take away 1 from 12. And so all we have to do is evaluate the expression 5 times 3 to the 11th power. And as you'll see, this formula comes in handy because we're going to end up with a very, very large number. 3 to the 11th power is 177,147. And then when we multiply that by 5, we get 885,735. So the answer to our question is our explicit formula is a sub n times 5, or equals 5 times 3 to the n minus 1, and our 12th term is 885,735. Okay, let's try another problem. Write the explicit formula for the geometric sequence, then determine the 6th term. So we're going to start out with our formula, a sub n equals the first term, a1, times the common ratio raised to the n minus 1 power. So we need to identify our first term. That one's easy. Our first term, a1, is going to be 100. But the common ratio is going to be a little different. You might be tempted to say that to go from 100 to 50, you're dividing by 2. But that's not really a ratio when we say division by 2. Or if we're going to say it's division by 2, we're going to have to write that a different way. So to write this as a ratio, we're going to create a ratio. What is 50 over 100? Should be the same as comparing 25 to 50. 25 to 50, since the ratio should be common. And sure enough, 50 over 100 and 25 over 50 both reduce to 1/2. And 1/2 is our common ratio. And for those of you who are familiar with the idea that every division problem is just a multiplication problem in disguise, will understand that I'm going to rewrite this division by 2 as multiplication by our common ratio, 1/2. So 50 times 1/2 is 25, and now we've identified, our common ratio. R is going to be 1/2. And so now we can write our explicit formula, a sub n equals our first term, 100, times, I'll put this in parentheses, 1/2 raised to the n minus 1 power. Now, to find the 6th term, or a sub 6 equals 100 times 1/2 to the 6 minus 1 power, or in this case, the 5th power. And for those of you who remember your rules of exponents, in this case, we can distribute this to the numerator and the denominator, the exponent to the numerator and the denominator. So that's going to be 1 to the 5th power over 2 to the 5th power. And that just simplifies to 100 times 1 over 32. And so I'll continue this over here. And that's just going to be 100 over 32. And if we use our calculator, that probably comes out to a nice decimal. 100 divided by 32 is 3.125. And so there we go. The answer to our question is, this is the explicit formula for the sequence. A sub n equals 100 times 1/2 raised to the n minus 1. And then our 6th term is 3.125. Okay, so why don't you pause the video and attempt this problem on your own before I explain it. So let's pause the video now. Okay, so let's start with our explicit formula, or the general formula for an arithmetic sequence. This procedure should be fairly familiar to you by now. All right, so our first goal is to find the first term of the sequence, and that's always easy when you're given the first few terms of the sequence. So our first term is -6. Our second goal is to find our common ratio. So what do we do to -6 to get 18? Well, it's the same thing we do from 18 to -54. So I'm going to show you a different way of looking at this. That is essentially another way of finding the common ratio. So before I was telling you, take the first term and the second term and compare them, putting the second term over the first term, and then putting the third term over the second term. So we'd put 18 over -6. That would give us our common ratio, -3. And if we do -54 over +18, that also gives us -3. And that's fine, that works. But now I'm going to show you why that works. We're going to model this using an equation that helps us answer the question, what are we doing to -6 to get +18? What are we multiplying -6 by? So we can write that as an equation. -6 times this common ratio r gives us a +18. And as you see, when you solve for r, what you get is the ratio that we have been writing down. And if you ask the same question, what do you do to 18 to get -54? Well, if you start out with 18 and you multiply it by the common ratio r, and you get a -54, well, when you solve for r, you're going to get that same ratio, -54 over 18. And both of these simplify to -3. So our common ratio is -3. So this may seem a bit simplistic for this sequence, but when we get to the next question, you will see why analyzing or answering this question in an algebraic fashion becomes very, very useful. Sorry, times -3, and here we're multiplying by -3, so our common ratio is -3. So now we can write the explicit formula for the sequence. A sub n equals our first term, -6, times -3 raised to the n minus 1 power. So now let's find the 10th term. A10 equals -6 times -3 raised to, and in this case, This is going to be 10 minus 1. That's going to be negative 3 to the 9th power. And we know that a negative number raised to an odd power is going to be a negative number. So we'd expect a negative number. And, sorry, negative 3 to the 9th. That's a little better. Okay, negative 6 times negative 19,683. And now when we multiply that by negative 6, we get a positive number, 118,098. So we've answered our question. Here's the explicit formula for the sequence. And here is our 10th term. Okay, so pause the video and attempt this one on your own. So let's start out with our model times r to the n minus 1. And same old, let's find the first term in the sequence. A1 is 3.15. Now, again, that's the easy part. Finding the common ratio is going to be, or takes a little bit of analysis. So you know how to find the common ratio comparing these two terms, but I'd like you to get used to creating a model. So we're going to ask ourselves, what are we doing to go from 3.15 to 6.615? What are we multiplying by? 3.15 times the common ratio r equals 6.615. And that's how we get this fraction, 6.615 over 3.15. Now, at times we're just going to have to keep it as a fraction like this, but if you plug that into your calculator, let's see what we get, and we get a nice decimal 2.1. Very nice. So our common ratio is just going to be 2.1. So I feel comfortable using that in our explicit formula. That's easy to work with. So our explicit formula is going to be a sub n equals our first term 3.15 times 2.1 raised to the n minus 1 power. Now, if we're looking for the 15th term, then A15 is going to equal 3.15 times 2.1 raised to the 15 minus 1, which is going to be the 14th power. And then if you just put this into your calculator exactly as it looks, you will get 102,183.4779. So our answers are here, the explicit formula, and the 15th term. And I should take a few moments to point out that the reason that you should understand how to model this problem algebraically and solve for it is because the common ratio here, multiplication by 2.1, was not obvious. And when you're working in a math class, you get problems that look more like, 2, 4, 8, 16. But when you're working in the real world, your measurements of real world data are not always so clean. They look more like this. And so to find the common ratio is going to take a little bit more effort on your part. All you have to do is create a model of the question that you are asking and then solve for the unknown. In this case, the common ratio r.